Welcome to the third Tridium Talk on Niagara 4.6 new features. My name is Rick Weisensale. I'm with the product marketing team, and here with me is Scott Hoye, the principal engineer for our topic today, which is the system database service. The system database service collects Niagara 4 entity data associated with components found in all the subordinate Niagara stations on the Niagara network. The entity data, or in other words, the tags and relations, are saved in a local database referred to as OrientDB. The entity data is made available at the supervisor for queries associated with end-user navigation and search results. This entity data is then automatically associated with the Niagara Virtuals on each Niagara station. This allows the designer to take advantage of the on-demand graphics feature in Niagara 4. In summary, the system database service enables a Niagara supervisor to examine all of the data, all the devices in the Niagara network and pull the entity data into a new system database. What we're going to see today are a quick review of what we learned in the previous discussion about bulk deploy, things to consider when designing remote stations to be utilized with the system database service, requirements when adding stations to the Niagara network, how to configure the system database service. We're going to look at the system indexing process, and then finally we're going to see the benefits of utilizing the system database from an end user perspective. During the previous Tridium talk related to bulk deploy feature, I showed how to quickly create a JSON 8000 station with both BACnet and Modbus devices from an Excel spreadsheet. First, I created the spreadsheet from a collection of templates. Then I created a JSON 8000 station from the spreadsheets. During this system database service presentation, I will be utilizing that same JSON 8000 station I created and additional JSON 8000 stations created from spreadsheets to show the benefits of combining these two new features. So let's take a look. What you're looking at is an end user experience which is created via two spreadsheets and is running in a JSON 8000. Using this approach, the designer can completely test and validate the station prior to integrating it into the supervisor. This design includes energy charts, it includes floor plans, it includes HVAC systems with associated chart data, it includes tenants with occupancy schedules, occupancy temperature settings, and the tenant-related HVAC systems. So first we'll look at things to consider if you want to integrate your remote stations using the system DB service. Some of the things I will discuss here are related to the end user experience that I have chosen to design. Individual end user requirements will vary from project to project and must be addressed accordingly. The main consideration is the supervisor must use the same tag dictionaries and a superset of the hierarchies for end user navigation as well in all of the subordinate stations. First, we will look at the subordinate station design. This end user design provides the customer with 4 different hierarchy options for user navigation depending on their role in the organization. The station also utilizes the standard dictionaries provided by Workbench and some very specific dictionaries that provide all the required tags and relations to support this navigation design. Next, we'll take a look at the supervisor. There are Niagara device folders used to provide geographic location down to the individual buildings. Within each building, there are empty icon folders used to create topics under which various aspects of the building will appear. These topics include energy, They include the floors in the building, the HVA systems, the reports, the schedules, and the tenants. Now, at the bottom of this list, there are three stations that are already, three remote stations that are already connected to the supervisor on this system. Now, in this supervisor, as I mentioned before, we have the same, or a superset of the same four hierarchies, and we have the same collection of tag dictionaries. In our supervisor, I already have three stations connected, and they're associated with the West Tier. Oops. I'm sorry, I got ahead of myself. When adding a station to the Niagara network, there are a few things one must consider. The system database service allows the designer to take advantage of the Niagara Virtuals to visually see the content of the remote stations. Having said this, it's critical one considers the impact of turning on the virtual components with respect to user security. By default, these users may have access to all the components exposed as Niagara Virtuals. Please refer to the System Database Service documentation for more details regarding this subject. Once the station is connected, the histories must be imported to the supervisor, just like previous versions of Niagara, and also alarms are still pushed to the supervisor as before. In our supervisor, I already have three stations connected and associated with the West Tier 2 building in Richmond, Virginia. Now I'm going to add a new station to be associated with the admin building in Boca Raton, Florida. First, I will discover and add the new station. Now, this step is very critical. While adding this new station, I want to be certain to enable the virtuals, because this is a key part of the new Niagara technologies that we're going to take advantage of with the system database. Now I'm going to go ahead and poll the station and get it online. And then I'm going to discover all the histories that are on that station and import them into my supervisor. And after doing the import, I'll pick all of these histories and create and activate an archive so I can get the histories into my supervisor for future testing. So now I have my station, my new station connected, and we want to get the supervisor configured to use the system database feature. The system database service will automatically collect and save the entity data created in the remote stations and make it available quickly at the supervisor. This approach is critical to the overall project design to instantly provide the same end user experience that was tested on the JACE. In this example project, design of the supervisor hierarchies are supersets of the individual remote stations and will cause the end user navigation tested in the JACE to automatically appear in the correct building. The first thing I will do is go into the Niagara Network virtual policies and enable the import PX files on demand. What this will do is, as I'm selecting the virtual components in my Niagara network, if the PX file required to display that device is not in the supervisor, it'll automatically bring it into the supervisor environment. To show what this means, I'll drill down into one of the remote JACE 8000s and look at PX views of various devices and other components. So we're going to look at a BACnet network first. Look at a few of the devices on the network. Notice the message showing up when the PX view is being loaded from the JACE 8000. Once loaded, this step will no longer be required to view other devices using the same PX view. So now I'm going to go down to a tenant area, and we're going to look at a schedule. Now, this is a new feature in Niagara 4.6. What I'm doing is I'm viewing a schedule through a virtual instance of the schedule with a new view we've designed that allows you to actually edit a schedule in a remote station from the supervisor without having to create some kind of a master-slave link. So the things that are happening here, I'm on the supervisor, but I am actually changing the schedule on the JACE itself. All right, now let's go and add the actual system database service. The first thing I'll do is I'll add this service to my services container. One might assume they would look for a system DB or a system index module, and they would find both if they did. The system database service is made up of multiple configuration sections that are built together one at a time with many options. As a convenience, Tridium has included a Niagara system index module with a typical configuration already predefined. So I will simply grab this predefined system database service, and I'll drop it into my station services. So now we're going to go look at the configuration of our system database service. By default, the system database service has no database type selected. At the time of the 4.6 release, the only database type supported is the Orient System DB. However, there may be other options in the future, so we don't want to assume that this will always be the selected type. Therefore, you must select it when you install the service. Now we'll move down to the local indexer and enable it because we have components in our local station that we want to index. The indexes are based on Niagara BQL query statements, Because I want the end user to see the alarm console on my navigation, I'm going to add that as one of the queries. In addition, I want to include the Baja folders I added in the Niagara network as topics. So I'll save this, and then I'll move down to the global indexer. And in the global indexer, I also want to add Baja folders. The reason for this is in my remote stations, I have assigned PX views for things like VAV boxes and whatnot, or tenants. I've assigned these views to some of the folders in the remote station. So I want to be sure that I index those folders as part of my process. Next, I need to open my individual hierarchies in the supervisor and modify the station scope to be used. I want to change it from the station to the system database. Now, I'm only going to do this for the admin hierarchy, but you would actually do it for all of them. Now I'll go back to the system database service and execute a local index. I can see here that the index ran, it was attempted and completed very quickly on the actual supervisor. Now let's take a look at what this supervisor looks like on a browser. Notice I see the geographic location of each building and the topics where I will display various aspects of the buildings after the global index completes. At this time, these topics are empty because I have not indexed any of the remote stations. The global indexer is the workhorse of the system database service. Depending on the number and size of the remote stations, it could take several minutes to complete. Therefore, it is set to execute at 2 a.m. when activity is typically low. Now, there will be occasions where you may have made a change to a remote station or you're integrating a new remote station. In those situations, if needed, the indexer can be triggered manually to pick up the new items. So here I have opened the global indexer and I'm requesting it to execute. What we see is that the state is currently in progress. It's going to be there for a little while because it takes time to do this. And we see the time and date when the execution was first started. We won't wait for a couple of minutes. We'll go to the end. And now if we look at the end, we can see that it's gone back to idle. And there's a recording of the successful completion. And at the bottom of the page, we can see that all 3 of our eligible Niagara stations were successfully indexed, and there were no stations down at the time. So we've got this supervisor that we've done all this indexing on, and indexing the remote stations has now made all of the entity data, the tags and relations, available at this supervisor level and stored in the system database. Because we can now use the Niagara Virtuals with on-demand graphics in conjunction with the stored entity data, the end-user browser experience has changed dramatically. So what we'll do is we'll open up a browser and we'll take a look at this experience having done the system indexing. When we last looked at the end-user experience on the supervisor, we saw these same topics that were results of indexing the local components. Now I will simply expand these topics and see what new information is available for these buildings because of the global indexing process. We can see energy summary data and individual meter data from the remote stations. We can see the main floor graphic from the remote station. And as we move down, we can start to see the HVAC equipment. As I walk down the tree, you will sometimes see the loading message pop up. These are the occasions where the PX file has not been copied up from the remote station. After this is done, you may notice opening the same view again does not result in a loading pop-up message because the PX file is already in the supervisor. So in this one, it's already there, so there's no need to load it. This site worksheet is both unique to the building and to the current user logged on to the supervisor. It provides a location where the user can drag data onto a page, save the individual sections by selecting the save icon on each one. The purpose would be the user is trying to diagnose some kind of issue in the building and wants to look at some charts and some real-time information. The user can then log off, come back later, and the same data will be on this page related to this building from the previous view. So now we're going to go down and look at some of the tenant information. Here again, we're looking at the remote schedule that we can edit easily with the new features. And also what we see is all of the associated, we can see in our graphic, in our hierarchy, we can see down here, we have the occupancy schedule and we have all of the related equipment that's associated with that schedule. Now I'm going to simply walk down the tree and show another building and how much data is available through our system index process. We see multiple floors with lots of HVAC equipment. As I scroll down into the tenant section, we can see the various tenants, and expanding the tenant, we can see the occupancy settings, and here again, we can see all of the equipment that is used. Now, what I've done here is I've logged off of my system and I've logged back on as an energy. Oh, excuse me, I'm getting ahead of myself again. I'm doing a search. I'm going to search for the air handlers using the tags that are being pulled in through the system database. So I found the air handlers. Now I'm going to search for some return air temperature sensors. In this situation, I found 9 of them. Well, I'd like to see just the ones that are on the air handlers, so I'm going to add in the haystack AHU, and here I see return temperatures for the air handlers, or I may say, show me the ones for the rooftop. And here I see return temperatures for the rooftop units. This is where I thought we were going, but so now what I've done is I've logged off the system and logged back on as an energy user. And as you can see, this energy user only gets to see information related to the energy of the building. And so if I log off and log back on as a tenant manager, and I start expanding the buildings, I will only see information related to the tenants. I can see here, I can see the tenant, I can see all of their occupancy settings, and I can also see the equipment related to that particular tenant. So let's review what we've learned today. As you look over these bullets, I want to make sure you realize what you just saw. Looking at this end user experience we explored, what you are seeing is due to a design of the tag dictionaries, the 4 levels of navigation provided by the specific hierarchies, and the very specific remote station design details. Just a quick reminder, these remote stations were all built using Excel spreadsheets and the Niagara 4.6 bulk deploy from Excel feature. Before the introduction of system database service, the system designer would have quite a lot of work to do with respect to getting a fully tested individual remote station end user experience to be available at the supervisor level. This typically can take hours for each remote station. But what you saw today dramatically simplifies this process. The steps were add and configure the system database service, enable the Niagara Virtual components while taking into consideration the impact on user security, enable virtual demand graphics, execute both the local and global system indexers, and then simply open the web browser and watch the magic happen. So that concludes our discussion for today. If you want to go back and see the videos from some of these Tridium talks, you can go to the link that's shown here, and you can download the previous talks. And this talk will be posted soon enough. And also you might want to watch for future Tridium talks on Niagara 4.7. Please use the Q&A button to ask questions. Oh, now we'll open up to answer some of the questions.
Okay, I see a couple questions have come in. This is Scott Hoye. There's a two questions that are related to those PX files that come in on demand. Are the JSON, the supervisor PX files, kept in sync once they've been loaded for the first time into the supervisor. Couple answers there. Yes, they can be kept in sync. Under the covers, it's actually using the file import. So it's importing the PX files across. When Rick didn't show it in the demo, but there's extra configuration you can do that you can say when to re-import those files. So you can set it up that once a night, I'm going to go re-retrieve the PX files from the JACE and pull them in. And then, so then the next time you go view that file on the supervisor, on the virtual, it will be updated. Or you can import them, you can re-import them on demand. So with these new virtual PX graphics, there's actually a new action, and you can say to basically to refresh the PX view if you think it's not in sync with the one, and it'll do it on demand when you do it. So there's two options. One is to periodically resynchronize them, or the other is to synchronize them intentionally when you want to do it. Next question related to that is once they're loaded on the web supervisor, do they stay there, or are they per session? Yeah, they do stay there. They're cached in the supervisor. So the next, if you log out and log back in, those cached virtual PX files will still be there. There's a question, how do we edit anything after the fact? Do we make the changes on the JACE and then re-index to the supervisor? The answer to that's yes. So if you change any tags or add components, we talked about entities. Entities are basically components that you have in the remote stations, the JACE stations. So information about those entities, such as their tags and relations, is what would get pulled into the supervisor when you index the station. So if you make any changes, then you just re-index. And the indexer at the supervisor can also be configured on a trigger, so it can, by default, it's re-indexing once a night. So any changes you make, by the time you log in the next day, it should have pulled in those changes. Okay, let's see. Can the PX pages in the remote station come out of a module, or do they need to be on the file system of the station? As with PX view tags, it says, I believe they need to be on the file system. Yeah, that's true. They need to be on the file system. So under the covers, it's using the same technology that we used for export tags, but now it's kind of doing that for you, so you don't have to set up the PX view tags and all that on the JACEs. It knows how to pull that stuff across. The licensing cost, Rick, do you know?
To the best of my knowledge, the licensing there's no additional licensing cost to use the system database. It's when you get upgraded to 4.6, it just becomes available. There's no licensing required.
Let's see, you showed us how remote schedules can be changed. Can other settings be changed? Yeah, basically anything that you could see on that HTML5 scheduler view, and any settings you can change there, you can do against a virtual schedule. So, so not just the days of the week changes, but if there's other settings that are available in that HTML5 scheduler view, then you can do that. One thing to point out there is that for the new scheduler view, it requires that the remote JACE that you're going through the supervisor to remote JACE, they all need to be 4.6 or later in that case. One of Rick's slides mentioned that to be indexed, you have to be 4.4 or later. That's true. So to be indexed, but to actually take advantage of that scheduler view on virtuals, that requires 4.6 all the way through or later.
Okay, this next question about the normal page with hyperlinks be created. I'm going to take a stab at understanding the question, but if you remember, when I went through the demonstration, there were some device folders and there were some folders in the supervisor, so you can assign views to those to all of those levels, and you can put hyperlinks on them just like before. I don't know if that answers the question, but and the next question down is about the VAV that is done with virtual points.
I think we have time for one more question. Are the example hierarchy structures available somewhere as a resource?
They will be. There's going to be a PDF file on the website that explains how what approach to the hierarchies I used in this design.
And then last quick one, is it designed specifically for JACEs or can it be used with other Niagara-enabled devices? Yes, it can be used with other Niagara-enabled devices that are connected to from the supervisor in the Niagara network, as long as those Niagara-enabled devices are 4.4 or later, they can be indexed. So I think that's all the
Yeah, I think we're out of time, but we will try to collect this list of questions and produce a document with as many questions as we can possibly answer and put them on the website. So we thank you for joining us today and hope you found it informative.